Set them. Set them.
Forgive myself. If you feel that way,
Okay. Hello and good afternoon. Please, can you hear me?
Yes, sir. We can hear you.
Okay. You're welcome. Today I want to finish up with the two topics that were left in the first slide, and then try to introduce differentiation by first principle. So we are going to look at the definition of limits and the limits at infinity, and then what we mean by whether a function is continuous at a point, continuity, and then hopefully look at differentiation by first principle. Because you can find all this in the PowerPoint. Then briefly show you where it is. So the first PowerPoint is almost about 90 pages, so it's made up of all the topics in the unit 1. So this from here going, we look at limits and the limits of a function, how to use a calculator to do it, and then it ends on the continuity as well. So you can find these things in the PowerPoint, but I'm going to use my Excel document so that we can go through these definitions and take examples on them, so that when we see a problem, we know how to handle it. Okay, so that is my approach. So I'm going to share my Excel document, and we'll use that to go through these three topics or 3 points. Okay, so you should see on your screen, I've extracted information from the PowerPoint and it is here. So let's define the limits of a function, okay? Let's define the limits of a function. Now, we say that the limits of a function f of x is a value to which the function gets close or tends to get close to a point. So when we are finding the limits of a function, they will tell you all the limits of a function at x approaches as a number. Let's say x is approaching a. So as x approaches a, we will write it as x with an arrow to a. And then we will find the value of that function at that point. So the limit of a function L is defined if and only if the sided limit, what we call the left-hand limit, and the right-hand limit, when you evaluate them, they give you the same value. Okay, so what we are saying is that what is the limit at, let's say, x equal to a? If we claim that the limit at x is equal to a, will give me a value like L. The answer is L. The answer is 10. The answer is 100. Then we must verify that when we approach the limit at a from the left-hand side, when we say left-hand side, that is from if a is like 2, from let's say 1.5 to 2. That is the left-hand side of 2. If that value will give you the same L, and then we approach the limit from the right-hand side of a. So right-hand side of 2 can be from 2.5 or 3. very close to the value 2. If that limit also gives you the same value as L, then the limit at x approaching A being L, we say is true. Okay, so diagrammatically, what we have here is that if you look at this figure, I don't know whether it's clear on your screen, we plotted a graph. We are saying that if point 2, where the point 2 is on the x-axis, we want to find limit as x approaches 2. So if we claim that the limit as x approaches 2, the answer is equal to 4, then we are going to look at as we approach from the left-hand side of 2, and then from the right-hand side of 2. If the value of the function is equal to 4, then we say that the limit as x approaches 2 is 4. Now, in the graph, in the plot, we are dealing with x squared minus x plus 2. Now, left-hand side from 2 will be 2. If you substitute 2 into the function, you get 2 squared minus 2. 2 squared minus 2 is 4. 4 minus 2 is 2. 2 plus 2 is 4. So you see that the answer here will still be 4. Okay, so let me make sure you understand. Please, any question on this? We want to make sure we understand the concept of the limit. Any question on this? Or we should go on and see whether an example will make it clearer. Hello, you guys, are you okay? Do you understand what I just explained? Hello, can you hear me?
Can you hear you, sir?
Okay. Okay, so I'm saying that if you need more clarity, let me know. So this is the definition of limits. Now we'll look at the properties of it, and then we take examples. So you can be asked a question to be able to find the limit of a function when the functions are 2. Let's say f of x and g of x. They can ask you what's the limit of x approaching a value for f of x plus g of x. So the properties of limits allows us to separate them. We can find limits as x approaches f of x plus or minus limit of x as x approaches a of g of x. So instead of adding the functions first before finding the limits, we can find the limits of the individual functions and then we add them. So that is addition and the subtraction rule. Limits allows us to do that. Now the scalar formula tells us that if you have a function and the function is being multiplied by a constant, then we can factor the constant out. If you are finding limit as x approaches a, factor the constant out and find the limit of f of x. And then when you finish, you multiply by the constant. Okay, so this also can be applied in the form of limits. For multiplication, if two functions are multiplying, f of x times g of x, let's say 2x times x squared plus 1. Instead of multiplying 2x and x squared plus 1 and get a cubic function, we can take our time rather and find limit of the 2x and then limit of x squared plus 1 and substitute the limit function into it. So it allows us to add and subtract, it allows us to multiply, it also allows us to divide. Okay, so if you have two functions dividing, you can find the limit of the first one divided by the limit of the second one. Okay, so these are the various definitions of limits. So now we want to take examples of what I have just explained. So here, this example is to help us to check the limit using the addition principle. So what is limit of as x approaches 2, 3x squared plus x to the power 4. So based on what we learned, if this is my f of x and that is my g of x, then I can find limit of f of x plus limit of g of x and then add it. Okay, so let's do it together. If I substitute 2 into 3x squared, I'm going to get 3 into brackets times 2 all raised to the power 2. And then for this one, if I substitute 2 into x, I'm going to get the value 2 raised to the power 4. Okay, so what is 3 times 2 squared? That is 2 squared is 4, and 4 times 3 is 12, isn't it? 12. And then for the right hand side, what is 2 raised to the power 4? Is it not 16? That is 4 for 16. That gives you 16. So 12 plus 16 should give us 28. Okay, so this is when two functions are being added. We can do that. We can try that of the subtraction 2. Limit of x cubed minus 5x. If you want to find limit as x approaches -1, means that let's substitute -1 to the power 3, okay? And then we substitute -1, that is 5 times -1, and then we evaluate all this. So -1 to the power 3 will simply give us -1. And 5 times -1 is also going to give us, remember we are subtracting, 5 times -1 will give me -5. So negative, or maybe let me write it as -5. Okay, so that will be -1, -1, so -1, -1 plus 5. And finally, that should give us +4. Okay, that should give us +4. Okay, so these examples basically are straightforward. Substitute the value of the limit into the function. Okay, so let's try that of scalar. So scalar, we have 3 multiplying x squared. So we said we'll factor the 3 out and then substitute the function 2 into the function. So this will be 2 raised to the power 2. That is x squared. So x is represented by 2. Now 2 raised to the power 2 is going to give me 4. So that gives me 3 times 4 will give me 12. 3 times 4 will give me 12. Then for multiplication, if we have x squared, I hope you know that x squared is the same as x times x. So if you have x squared, we said we can find limit as x approaches the first x and then substitute the second x. I hope you can check. If you put 3 here, we are going to get 3 squared. And 3 squared is going to give me 9. So if I break them down into individual x, so if I substitute the value 3 here, limit as x is equal to 3, and limit as x is also equal to 3 here, you virtually are going to get 3 times 3. We get 3 times 3. And the answer will be equal to 9. That is if you substitute 3 here, and then you square it. Okay, then the last one for the properties. When we have x cubed divided by 2x, so limit of this function as x approaches 5. So we're going to substitute the value 5 into the numerator. So 5 raised to the power 3, all divided by 2 times 5. Now 5 raised to the power 3, that is 25 times 3. 3, 15, 3, 2, 6. Is it 75?
75.
Okay, 75. All divided by 2 times 5, which is 10. So that will give you 7.5 as an answer. Okay, so these are the properties. I've given, I think, some few questions here, 3 questions here. If you can try this on your own, maybe you can try one. This will be, I haven't written the formulas, but basically you must find limit as x approaches 2 and then add this. So limit as x approaches 2 is going to be 2 all raised to the power 2. As for the constant, is already a constant, so that should be plus 3. So 2 squared will give you 4. 4 plus 3 will give you 7. Okay. And then for this one, find the limit of the following rational function. This one, first of all, you must expand this. X squared minus 4. Is it not difference of 2 squares? So this should give you x plus 2 times x minus 2. Okay. And then if you divide it by x plus 2, you are going to get the numerator cancelling. This x plus 2 will cancel the denominator. So your limit function is going to reduce to x minus 2. Now then you can substitute the negative 2 into the function. So please, for rational function, when you are supposed to find limits, make sure you expand and make sure that you have simplified to the lowest fraction before you substitute. Or else you may get an answer which is not what you expect. Okay, so this will be minus 2 or minus 2. We are substituting x equal to negative 2. And that should be equal to negative 4. Okay, so I hope we understand the definition of a limit. Basically, if you substitute the value of the function, value of x into the function, then we evaluate these functions at those limits. Okay, then the second part of this limit is limit to infinity. Now, to do that, we need to explain some few terms. Now, given a finite number, let's take note of this. If you are given a finite number, a, the concept of infinity is when a is divided by 0. Now, on your calculator, if you try to divide any number by 0, the calculator will tell you undefined. But please, the concept here is not necessarily 0. We are coming very close to 0. Okay. Yesterday I did a simulation on this. If you are approaching 0, then the function a divided by 0 should approach infinity. So that's a property in limits. This is only applies to limits. It's not in normal algebra. Algebra 2 over 0 will be undefined, or a function with a denominator being 0 will be undefined. But in limits, we are allowed to write things like this. So take note, when a number, your denominator is 0 for a limit function, then that function must approach infinity. And then when you have your number and your denominator rather is infinity, any number divided by infinity, imagine infinity is a big number. If it's dividing any number, then the number must be close to 0. So these are the two concepts when our values of limit goes to infinity or goes to 0. Okay, so please take note of this definition. Now, these are the steps you need to take if you want to find the limit of a rational function. It is only fractional or rational functions that we sometimes get into situations like this. So to find a rational function, limit of it, locate the variable with the highest degree. So in the rational function, the numerator of a rational function is a polynomial to the power x, maybe linear, quadratic, or cubic. So first of all, they're asking you to locate the highest degree of locate the variable with the highest degree. Then divide each of the terms of the function by the variable with the highest degree. Now, when you are through, you substitute the value of the limit into the simplified function, and then you evaluate. Let's take an example to explain this point. Okay, so let's take this particular problem. I have 3x plus 7 in the numerator, and then 2x squared minus 4x plus 5 in the denominator. So based on what we have read, what is the highest degree polynomial in this function? What is the highest degree? The numerator and the denominator. What is the highest degree? Do you
So
understand by what?
the degree is 2.
Yes, the degree is 2x squared.
Yeah.
So it means that
Yeah.
when we pick the first function, 3x, we are going to divide 3x by x squared. That's the point you are making. So divide this by x raised to the power 2. Divide all the terms in the polynomial by the highest degree, 7 divided by x squared. So you have to take your time and do all this. Then come to the denominator. The denominator, remember that we have 2x squared. 2x squared. So we divide this by x squared. And then here we have, why is this thing plus here? This should be minus. Okay, so minus 4x divided by x squared. Then we have a plus 5 also divided by x squared. Okay. Now that we've done this, let's simplify. Now, 3x divided by x squared, you'll be left with 3 over x. I hope you can see that. 3 over x. And then the 7 will remain the same. There's no x in the numerator. The denominator will be still x squared. And then when we come to the denominator, here, the first number is 2x squared divided by x squared. So it should be left with the value 2 because the x squared will cancel the x squared. And here, we are going to be left with 4 divided by x. And then we have 5 divided by x squared. Okay. So now, what do we do next? What do we do next? Since we are simplified to the limit, we have been able to simplify to the limit. Simplify to the lowest fraction. We can't do anything anymore. So wherever we see x, we are going to take our time and put infinity there. And please remember, what is any number over infinity? I wrote it at the top here. Any number over infinity goes to 0, okay? So we are going to place infinity at the denominator here. So here, this will be 3 divided by infinity. The only problem with this is I have to picking all these things one by one. 3 divided by infinity. And then here, I will have 7 also divided by infinity squared. And whatever that is, let me take my time and do this. The other ones, we are going to just substitute 0 for all those functions. And then here, I'm going to have 4 divided by infinity. And then this will be infinity squared. Okay, now, so please, this will be 0. I hope you see this. This will be 0, and that will be 0. So the numerator is going to be 0. And then this value will be, this value is going to be 0, and that will be 0. So all this divided by 2. Okay, so what is 0 divided by 2? So this is as limit as x approaches infinity. So 0 divided by 2 should be what? Is it not 0? Hello? 0 divided by 2, is it not 0?
Yes, sir, it's 0.
Okay, so this whole function, after simplifying it, should go to 0. Okay, so this is what makes these functions or limit or rational functions behave like that. Now, then we will have some cases. What are these cases? Sometimes the rational functions you have, the numerator and the denominator will have polynomials to the same degree. So we want to use some very quick analysis to be able to solve this so that it's not every time we divide the highest degree of polynomial with all the terms. Now, the first property we see here is this. We are saying that if f of x and g of x have the same degree, you look at this. Here, the degree in the numerator is x squared. The degree in the denominator is x squared. Now, if that occurs, then from what we are going to see, the limits of the rational function or the rational functions should be the coefficient of the variables with the highest exponent. So if you look at this, because the highest degree is x squared, and the highest degree here is also x cubed, and also x cubed. When we substitute whatever, the infinity to it, it will reduce to the coefficient of the polynomial in the numerator. The coefficient of x cubed in the numerator is 2. Okay? And the coefficient of the polynomial in the denominator is 4. Okay? So since the degrees are the same, you take the coefficient of the highest polynomial. So your final answer will be, as x approaches infinity, this polynomial or this rational function will approach the value 1/2. You simplify it and you write it. So this is because the function on the numerator and the denominator have the same degree. Now, what about if the degree of the numerator is greater than the degree of the denominator? Okay, so if the degree of the numerator is greater than the degree of the denominator, then the limit approaches infinity. They are telling us. So we'll look at the numerator. The degree here is 3. The degree here is 2. So please, this one, if you go ahead and use the what do we call it? These steps that are itemized here, step 1, 2, 3, 4, locate the highest degree, divide through by whatever, the answer you will get is infinity. So observing this, if the degree of the numerator is higher than that of the denominator, please don't waste your time. This is going to be infinity based on what we have done so far. You approach infinity. And then if the degree of the numerator is less than that of the denominator, you will see that the answer will be equal to 0. And that is the example we did up here. I hope you realize what we did here. When we finished, you saw that the answer was equal to 0 because the degree of the numerator is less than that of the denominator. And so when you simplify by dividing through by the highest polynomial, your function will approach the value 0. Any questions? I hope this is clear now, but I want to be sure we all follow. Do you have any questions on this so far? Okay. I have uploaded some worksheets on the LMS, like I sent to you. I've been sending to you at the end of every lecture. So there's a worksheet on continuity. There's a worksheet on limits and also differentiation. I haven't sent any yet, but I'll do that after we are done. Okay, so this will bring us to the end of limits. Okay, so the limits of a function, these are the types you will get, either limit approaching a value or limit approaching infinity. And if it is linear or is quadratic or is polynomial to the power 3, you just substitute. But if it happens to be a fraction, a rational function, then you will use the concept we have learned right now. If the degrees are equal, then you take their coefficients. If the degrees is greater in the numerator and the denominator, then the answer should be infinity. But if the degree of the numerator is less than that of the denominator, then your limit will approach 0. Okay. Okay, so now let's come to the concept of continuity. Concept of continuity. A function is said to be continuous if the limit of that function my laptop was not charging, so if a function is said to be continuous, if the limits of the function exist. Okay, so what are they trying to tell us? Mathematically, f of x is continuous at a point. We want to find out whether the function will be continuous at a particular point. So they will give you the value of the point. And then you substitute the point into the function. So if you substitute the point into the function of f of x, and the value becomes, the answer is equal to f of a, then we can say that the function is continuous at a. So these are the 3 steps you must go through. First of all, define substitute a into the function. And if you substitute a into the function, and the function is defined, it must be finite. It must be a finite number. Okay, Philip, you have your hand up. Engineer, what's your question, please?
Sir, please, this Excel, can we have it by the end of the lecture?
Yes. Oh, definitely. I was still working on it when you came, so I should have dropped it on the LMS. But when we finish with the work, I will just either send it to you, put a copy on the LMS as well, and put one in the chat. So I will share
Okay.
it with you. Definitely. Okay. Okay, so we are looking at continuity, and I'm saying that there are 3 steps you need to go through. 1, substitute the value of the function, the point you want to test. So if they're asking you, is the function continuous at a value a, then substitute the value a into the function and check whether the function is defined. That's step 1. Now, when you are done with that, then you also will let x approaches a of the function. Does it exist? Now, if the limit as x approaches a of the function is equal to f of a, then we say that the function is continuous. So let's test this theory with an example here. So we want to determine if this function below is continuous at x is equal to 1. Now, this function is defined in 2 parts. 1, 3x minus 5 when x is not equal to 1. Okay, 3x minus 5 when x is not equal to 1. But when x is equal to 1, the function is defined as 2. So they've defined this function in 2 forms. And the question is asking us to test, is this function defined at x is equal to 1? So we want to go and look at step 1. Step 1, what is f of a? Function of a. Now, our a here is the value 1. So if you look at this function defined, x equals to 1 is defined by this value 2. So if we substitute f of 1 into the function, my answer will be equal to 2. I hope you understand. We won't use 3x minus 1 because 3x minus 1 is for when the value of x is not equal to 1. And the question is being tested at x is equal to 1. So we will pick the second part of the function. So when we substitute testing for step 1, f of a, which is f of 1, we are going to pick the value 2. So f of 1 is equal to 2. And this function is defined. And also, it's a finite number. That is test 1. So the first condition here has been met. Now, let's go to the second condition. Let's substitute limit as x approaches a. Okay, so limit as x approaches 1. We must substitute into f of x. This time, we must use the first function. Okay, so as x approaches 1, remember, the first function, they said when x is not equal to 1. So we are going to substitute 1 into 3x minus 5. Now, 3x minus 5 is going to give us 3 times 1, which is 3, minus 5 will give me minus 2. So now let's check. Is the second condition, what is the second condition? Does f of x exist? When we evaluated 3x minus 5 at 0.1, we got minus 2. So it means that the value minus 2 is a number, it exists. The second condition exists. Now, the third one is to compare the limit we have just calculated to the function of 1. If they are the same, if these values are the same, then we say that the function is continuous at that point. But we know that from what we have done so far, function at 1 was 2. Limit as x approaches 1 was negative 2. So since limit as x approaches 1 was negative 2 and it's not equal to the value 2, the limit as f of x approaches 1 is not equal to when f is equal to 1. Therefore, the third condition fails. And hence, you can say that this function is not continuous at the point x is equal to 1. Okay, so you take your time and go through the 3 steps. The 3 steps are 1, evaluate x equal to a for the function, and then check whether the answer is a finite number. Then substitute x is equal to a into the function of x. And if also that function exists, compare this step 1 and step 2. Are they the same? If step 1 and step 2 are the same, then we can say that the function is continuous. But if they are not the same, then we conclude that the function is not continuous. Okay, so there's one here. Let's try this one and see. Is the function f of x giving us x squared minus 9 divided by x plus 3? Is this function continuous at x is equal to minus 3? Explain your reasoning. So please remember step 1. We are supposed to find x at a. So a function f of x is continuous if when substitute x is equal to a and limit as x approaches a, f of x equal to f of a. This is what we are supposed to show. So we must first of all take our time and substitute these functions into this. But remember, this is a rational function. So we are going to, what's the word? We are going to place the numerator in the form of its factor. The numerator is difference of 2 squared, x squared minus 9. And that should give us, what should this give us? X plus 3, isn't it? X plus 3, and then x minus 3. Okay. So and then the denominator will be x plus 3. Now, then that function will reduce to the numerator, x plus 3 will cancel the denominator x plus 3. And so we'll be left with x minus 3. Now, if you substitute the value negative 3 into this function, we are going to get negative 3 minus 3. That gives us negative 6. So limit as x approaches negative 3. Limit as x approaches negative 3 from the negative side was negative 6. So here, if you substitute x equals to negative 3 into the function, what is limit as x approaches negative 3 from the positive side? It will still be, if you approach from the positive side, it will still be this x minus, or that will give you 3 minus 3 minus 3. So that will give you minus 6. Okay, so therefore, limit as x approaches negative 3 is giving me the answer to be negative 6. Okay, so this is the limit function. Now we must evaluate f of x. We must evaluate f of x. So we are putting negative 3 into the original equation, which is x squared minus 9. We have found the limit. Now we want to find function of x. So what is x at negative 3? So this will give me negative 3 all squared minus 9. And then we have negative 3. What is this? Negative 3 plus 3. Okay, now the numerator is going to be what? That will give me 9 minus 9. And what is 9 minus 9? That is 0. And the denominator also is going to give me 0. Okay, so what is 0 over 0? This 0 over 0 is not equal to the negative 6 we found. I hope you know what we are trying to show. F of a should be equal to limit of x approaching a. So when we did limit as x approaching a or minus 3, we got minus 6. But when we substitute minus 3 into the function, we got 0 over 0. And it's not equal to the minus 6 we got. Okay, so since f of minus 3 is not equal to limit as x approaching minus 3, we will say that this function is not continuous. Remember, they said we should explain our reason. Since f of x give us a value to be equal to give us a value to be equal to 0 over 0, and it's not equal to x minus 3, limit as x approaching it, we can conclude that this function is not continuous. Okay. Okay, so we have gone through an example. We evaluated f of -3. It gave us 0/0. Then we evaluated limit as x approaches -3. It gave us -6. We are saying that since these two answers are not the same, this function is not continuous at -3. Now, there's an example here, which I recommend you also try. Whatever your effort will be, I will, when we meet, if next week, or maybe during the week, you can let me know. I will try as much as possible to see what you are getting, and then we can respond to it. But I want you to give it a try. So this is an example for continuity. Okay, so that will take care of the first two. I'm left with the last one. This one is going to just be one example. And to do that, let me just go through the PowerPoint on differentiation, and then we can be able to continue from there. The PowerPoint also on differentiation, I am still working on the other part. Remember, I'm only looking at first principle. So I don't have all the materials ready. That's why I have not put it on the elements. But hopefully by the end of the weekend, I should be able to share that as well. Okay, so this should be our last example based on what we've done so far. So this is a PowerPoint on what these are the areas we'll be looking at in this material. But like I said, I haven't gone through it. I've done only the first two points. So the definition of a derivative of a function, and what do we mean by differentiating a function using first principle? What do we mean by differentiating a function using first principle? Okay, so this is what we mean by differentiating. Mathematically, the derivative of a function, if a function is given in terms of f of x, then it's denoted as dy dx. Okay? Now, some books will say d f of x over dx. That is differentiate respect to the function of x. Or when we use capital D multiply f of x, it also means dy dx. Or using d subscript x of f of x still means the differential of x. Or some books will say y prime or f prime of x. So all these terminologies are referring to differentiating a function. That's the first thing we need to know. Okay. So when they say you are giving a function and say find dy dx or find d, and if the function is defined as f of x, they can ask you to determine d dx of that function. Or they can say find y prime of that function. Please, all these terminologies are allowed in mathematics for differentiating a function. Now, so how do you approach this, or how do you do this using what we are referring to as the first principle? Okay, so basically, first principle is using what we call the slope method or the gradient method. So we want to understand that concept. So let's say that you are given a function y is equal to f of x. Now, so to differentiate that function, we will say that dy dx is the limit as change with respect to x. The difference as, remember when you are finding the slope, is change in y over change in x. I hope you remember that formula. Okay, so we are borrowing that formula in this sense. So dy dx is limit as your change with respect to x becomes very small. Okay, so dy dx is when the denominator becomes very small. So if you are given two initial points, x1, y1, like this, that x1 will represent your x coordinate, and then your y1 will represent the function of x. While your final point, x2, y2, that x2 will represent an increase in x, and then your y2 will be the increase in the y value. Graphically, this is what we mean. That's all I'm trying to show you. Okay, so we want to differentiate this curve that has been given. Okay, this curve. And if you are taking 2 points on the curve, my x1 and then my y1. My x1 is x, my y1 is f of x. And then for my x2 is the increment from x to x2. So that gives me x plus h. And then for my y2 is the increment from f of x to f of x plus h. So when we say that, what is the slope? You know slope is dy dx. So change in y, which is the numerator, function of x plus h minus function of x, all divided by x2 minus x1. That would be x plus h minus x. Okay, so when we put this into an equation form, we are going to get the gradient of that curve is change in y over change in x, which we are referring to as y2 minus y1, x2 minus x1. But so far as the graph is concerned, f of x2 minus f of x1 all over x plus h minus x. Now, the numerator will remain as function of xh minus f of x, and the denominator will simply reduce to the value of h. And then what we have just learned limits. As h of x or h approaches 0, it means that this denominator will disappear. So finally, when you evaluate any function using first principle, when you add h to the x and then subtract it from the original function, then you divide the whole thing by the value h. And from there, you should be able to evaluate your function. So my slide is just 3, and this is where how far I've gone to. So we'll continue with an example in the Excel, and then I hope we can then concentrate on doing more exercises on this. Okay, so I have 2 examples, and it's only one I have tried to work at. Okay, so if the question says differentiate y equals to x squared, y equals to x squared using first principle, you are being restricted to first principle. So please remember the formula we wrote earlier. We said if my original function happens to be x squared, then my increment is going to be x plus h squared. So original function is x squared. So add h to it, it becomes x plus h squared. So if I substitute it into the formula that we had in the PowerPoint, then the numerator will give me x plus h all squared, all minus x squared. When you expand this quadratic equation, you get x squared plus 2xh plus h squared. Then when I subtract the original function x squared from it, this x squared here will get rid of this x squared here. Okay, I hope you can see here. You need to get this one right. So I'm saying that this function is going to reduce. Please let me just copy it like this. Okay, so let me just change the color so we can see what we are doing. Now, so all I'm saying is that with what I have done right now, when I expand this x squared here will be gotten rid of because you are subtracting this x squared from here. Okay, and then if you divide through by h, see that h will cancel this h here. So the next time I write this, I'm supposed to get in the numerator, I'm going to get 2x. What happened? In the numerator, I'm going to get 2xh, 2x all plus h. I hope you agree, because this denominator will cancel the h that you have here. So 2xh all plus h. That's what you should have. Okay, because this h will cancel one of this h here, and this h will cancel the h here, and then we'll be left with 1 here. So what happens if we let h approaches 0 in this equation? If you let h approach 0, h approach 0, what would the answer be equal to? Anyone? Wherever we see h, let it approach 0. So what would this equation be equal to? 2xh plus 0. Your answer should be what?
Say 2x.
2x. Okay. So simply if you know the chain rule says that take the power to multiply the x and reduce the power by 1. That will give you 2x, and 2 minus 1 will give you 1. So if you use chain rule, differentiating this function would have been 2x. But they asked you to use what we call first principle, and that was what we have done. So this x squared will reduce to 2x, and that is the answer we have at the bottom here. Okay, so all the equations that you have, if they ask you to do the same thing with this, it means that when you expand this, this is going to be x plus h all squared, then 4x plus h. I mean, we have to substitute it into this equation. And then you do the same thing with this. Maybe I should try and do this one as well. Let's do this one. Since this is my last example, let's see if we can. Okay, so the x squared plus, the question was x squared minus 4. So this will be x squared minus 4. Am I right? X squared minus 4x. Okay, so what should be f of x plus h? That means that this will be x plus h all squared minus 4 into bracket x plus h. So while this is my function of x, f of x, this is my function of x plus h. Okay, so now we are going to substitute this into this equation. Let's substitute into this equation for the sake of the work involved. So I'm copying that hook and then we change it one by one. Okay, so this is my original equation. So my original f of x plus h is going to be this x squared that I have here. So here, I'm going to get x plus h all squared minus 4 into bracket x plus h. Okay. All this divided by h. Now, and when we expand this, it's going to give us exactly what we got here. X squared plus 2xh plus h squared. And when we expand this one, what do we get? That should give us what? That should give us 4x. So minus 4x minus 4h. I hope I'm right. Minus 4x minus 4h. Okay, so what happens when we subtract sorry, what did I do? This whole thing is representing is representing f of x plus h. So then we subtract the original function here, x squared minus 4x. So minus x squared Hey, this thing not working. It's not working. Okay, x squared minus 4x. All divided by h. Okay, so this x squared here will take care of this x squared there. And then 4x here will take care of this 4x here. So my numerator is going to reduce to 2xh. Well, let me create the fraction first. Hey, editor. Okay, so we have in the numerator, we were going to have 2xh plus h squared. What else will be left there? So 2xh, this will be left h squared. 4x is gone, so minus 4h, and then what else? Then that's all divided by h. Is am I right? I hope I'm right though. So x squared is gone because it's you subtract it from here, and then 4x2 is gone. I'll be left with 2x squared, 2xh, h squared, and then minus 4h. Now, if we let h cancel the h in the numerator, that will reduce to 2x plus what? 2x plus h. Is it plus 4? I should think so. 2x plus h plus 4. Okay. And then if I let h approach infinity, sorry, h approach 0, then the answer should be 2x plus 4. Okay. The answer should be 2x plus 4. So your final answer here y dx. Final answer to dy dx should be 2x plus 4. So this is differentiating by first principle. I have a few questions which I will drop in the. I'm going to drop in the chat room. This example just that c plus minus. This is what we just did. Example we just did. 4x squared minus 4x. So I think you 2x minus 4. Okay, so I'm going to drop these tutorials on the LMS for you to try your hands on. There's also another one which you can also go through. You are being asked to prove by first principle 3x squared. Then also this. I haven't tried that of sine functions, but I am sure if you know what happens when you differentiate the trig functions, you should be able to handle it. So basically, that is what I have for you today. Today, basically, we looked at three things. The first one was on limits. The other one was on continuity. And the last one is on differentiation. And we have looked at the first principle. When we learn the other strategies in differentiating functions, you even will realize that you can sometimes use the calculator to differentiate these functions. and you can get the answers you want. So any questions, any comments? I'm done. I will be dropping the files like you recommended right now. So if you have any questions or comments, let's have it.
Uh,
Yes, I'm listening.
W, so the sheets, if we write on paper and scan it and upload, is it okay, or unless we type it?
Oh, you can just imagine how long it takes to type.
Mm.
Typing would have been beautiful, but please, I'm looking at the time it would take for you to type all this. So please, you can write, scan them. When you scan them, convert them to PDF, and then you
Okay.
can upload it. And when you convert to PDF, it becomes sizable. But if you leave it as a picture, the sizes of JPEGs and PNGs are quite huge. So scan and then convert to PDF, then you can upload them for me.
Okay.
Okay. So now, okay, so I'm dropping the file right now. I'll drop them in the chat room and I'll send a copy to. I'm told today Kinsley is not around, so who will receive it for me? Who called me? Was it Nathaniel?
To be Engineer Philip.
Oh, okay. So I'll send you a copy if that's okay. But if you want, look at the chat room right now. I'm just dropping a copy there so that you can download if you are not using a phone. And okay, and then the documents I just recommended, worksheets on continuous functions and also on limits. Some of them have answers, but please, even if it has answers, kindly work through them so you are able to get the answers, so that you are very conversant with it. Now, all these files I'm sending, I'm going to send copies, place them on the LMS as well, so that you can download if you can't download right now. Okay. So, God willing, next week, the areas which I showed you, with respect to the differentiation, we are going to look at the rest of the methods that is used to differentiate these functions. So if you want to read ahead, the model book online, there's a model book online. We'll look at the chain rule, we'll look at the product rule, we'll look at the quotient rule, we'll look at differentiating using differentiating exponential and logarithm functions. At the same time, then we'll look at some properties of these functions and how they behave. I hope by then I have uploaded the PowerPoint so you can even read ahead. Okay, so we'll continue next week, God willing. If you don't have any more questions for me, God willing, next week we'll take it up from where we have left off. But please practice these questions for me, and those ones you are able to then submit them as well. Okay, so enjoy the rest of your weekend, the rest of your class. Yeah. Bye for now.